Okay, so we just did number one, which the two events were flipping a coin and getting tails, and then picking a day out of the week with the letter T, right? And we just talked through that on that first video. So now we're here on number two. So number two actually has three events. They're actually the same three events. So a die is rolled three times. Low key, the word die is the plural word of the word dice. So if you're only working with one dice, you're working with a die. That's what that means, okay? So one die means you have one dice, right? And I'm going to roll it three different times. They're independent because every time I roll that dice, I can still get a 1 through 6. So the first time I roll it, I can get a 1 out of a 6. The second time I roll it, I can get a 1 out of a 6. Third time, again, 1 out of 6. What I want to know is what is the probability of getting 1s on each roll. So if we go to our work, I want to find the probability of getting 3 1s. So I have, again, three events. I have event 1, which is getting a 1. I have event 2, which is, again, getting a 1, right? And then, again, I have event 3, which we're getting wild here, is, again, going to be getting a 1. So what I'm going to do is I'm going to find the probability of the first event, the probability of the second event, and the probability of the third event. Like, legit, that's all it is, all right? So the probability of getting a 1, if I have a dice, it has 6 sides. It has a 1, a 2, a 3, a 4, a 5, and a 6. I roll my dice once. The probability of getting a 1 is just going to be 1 out of 6. Then again, I have that same dice. It does not matter what I just rolled because I'm going to roll it again. So it's completely random. All 6 of those options are still available to me. It's not like I rolled my 1 and then I erased that little dot. No, I still only have a 1 out of 6 chance. And you guessed it, probability of getting a 1 again is 1 out of 6. Legit, all we're going to do is take these 3 probabilities and multiply. When you multiply probabilities, you multiply the tops, you multiply the bottoms. So 1 times 1 times 1 is, well, 1. 6 times 6 times 6. 6 times 6 is 36. 36 times 6 is 216. That's it. That's all we're looking for. So again, I found the 3 different probabilities, multiplied those 3 probabilities together, and got my final answer. Let's go ahead and look at number 3. So number 3 is the spinner. So I'm going to spin my spinner picture below twice. So because I have my 2 events, that's what's making it compound. And I want to know what is the probability of getting an even number on both of those. All right, so if I look at my spinner, it's basic, right? I have 1, 2, 3, 4, 5, and 6, which is kind of low-key the exact same thing as rolling a dice. But anyways, so I have options 1 through 6. So let's go ahead. We're on number 3. And then I want to know what is the probability of getting an even twice. So it's saying twice, which means I have 2 events. I have event 1 and I have event 2. My first event is going to be, well, getting an even. My second event is, again, going to be getting an even. My spinner has 6 sections. There. 1, 2, 3, 4, 5, 6. They're all equal size. I just don't know how to draw, so you're welcome. Of those 6, this guy's even, and this guy's even. So out of those 6, I have 1, 2, 3 even sections, which means the probability of getting an even is going to be 3 out of a 6. Now, act like that first event didn't even happen, right? I'm looking for my second event, which is, again, getting an even. So I have the exact same spinner. Out of that spinner, I still have 1, 2, 3, 4, 5, 6. So my sample space is 6. Of those 6, 3 of them are even, which means my first probability is 3 over 6. My second probability is 3 over 6. Multiply the 2 together. 3 times 3 is 9. 6 times 6 is 36. Reduce. You can reduce by 3 if you want. You can reduce by 9. If you completely reduce, you should end up with 1 over 4. Let's keep it going. So number 4 is a little bit more wordy than the other ones. So number 4 says a jar contains 4 blue marbles, 5 red marbles, and 3 green marbles. If I can pick 1 marble from the jar, put it back in that jar. So that's what makes this independent, because I'm taking a marble out, looking at it, putting it back in, so my total stays the same. Then pick another marble. What's the probability of getting 2 blues? Okay, so we're on number 4. Number 4, I have a jar, and in my jar, I have 4 blue.
Hang on.
Alright, you good?
Yeah.
So 1, 2, 3, 4. 4 blue. I have 5 red. 1, 2, 3, 4, 5. 5 red. And then I have 3 green. 1, 2, 3. My goal is to find the probability of getting a blue, putting that blue back in, and getting another blue. All right, so I have 2 events. Event 1 is finding 1 blue. Event 2, I'm putting that marble back in, and then I'm finding another 1 blue. Okay, so I need to find the probability of getting 1 blue. So just ignore that second event for a minute. All I need to find is the probability of getting a blue, which means I need to know my sample space. If I add all these up, I know total there are 12 marbles total. So I'm going to make this first one out of 12. Out of those 12, 4 of them are blue. So I know to start, the probability of getting a blue is just going to be 4 out of 12. I'm going to take that blue marble out, which I had a 4 out of 12 chance. I'm putting that blue marble back in. All right? Because I put it back in, I still have a total of 12 marbles. Of those 12 marbles, I still have 4 of them being blue. So my first event was the probability of getting a blue, which is 4 out of 12. My second event was, again, the probability of getting a blue, which, wild here, it's the exact same thing. Still 4 out of 12. So if I have my 2 4 out of 12s, 4 out of 12, multiply those bad boys together. 4 times 4 is 16. 12 over 12 is 144. Legit, all I'm going to do is divide by 2 because I'm lazy. 16 divided by 2 is 8. 144 divided by 2 is... 72, yep. And then again, divide by 2, 4 and 36. I'm gonna divide that one by 4, 1 and 9. Yeah, so our final answer completely reduced there is gonna be 1 out of 9. Again, if you have any questions, please do reach out like as soon as possible. I know this one was probably like the harder one for us, but once you see that all we're doing is multiplying the 2 probabilities. Hopefully that made it a little bit easier. All right, miss you guys. Have a good day. Love you. Bye.